So I want to take a couple minutes here and just hit a topic once again that we've kind of danced around, we've looked at a couple different times, but I want to dive again into it just a bit deeper, and that's the autoignition properties, the ignition properties of the fuel. And specifically when we talk about ignition properties, and we've already mentioned this with gasoline, we're talking about octane. So it's an octane rating. So it's a number that we give to a fuel that quantifies its autoignition properties. For diesel fuel, we look at cetane. So it's a little bit different number, and it actually goes the opposite way. All right. So octane, again, both of these numbers, both of these indications are quantities that tell us what the autoignition properties of the fuel are. Again, when I compress a fuel, its pressure goes up, its temperature goes up, and that fuel is going to ignite. So it ignites by itself. The question is, at what pressure do I want that ignite? And that becomes very critical to us for different reasons, depending on whether we're talking about spark ignition engines for gasoline and ethanol, or a compression ignition engine with diesel. Okay, so octane rating, and we've talked about this. A higher octane means a higher ignition pressure. So I can only compress that fuel so much. In a spark ignition engine, I don't want that stuff to ignite by itself. I want to ignite it with a spark whenever I want it to, so I can control when that happens. And so I got to limit those pressures. So if my pressure gets too high, it ignites early. That doesn't work well for the engines, but I can maybe compensate with that with a higher ignition pressure. And we mentioned that with ethanol, that we can have that higher, it has a much higher octane rating, a much higher autoignition properties, so we can get a lot higher pressures in our engine. So sometimes with a lower energy content fuel like we have in ethanol, I can get more power from it just because I can have higher pressures. I can get that auto ignition, that pressure up before it auto ignites, and I might be able to expand that PV curve that we looked at, make that bigger, get more area in between those curves, get more power out of it. So it all depends on how those different things work out. So that's octane. Higher octane is higher ignition pressure. Now in our compression ignition engine, the opposite thing is happening. I get that pressure up to a certain point, and I want to hope that pressure is high enough with the air that I've compressed in that combustion chamber so that when I inject the fuel in there, it's going to ignite. So I'm better off to have a fuel with a lower auto ignition pressure. So I want that stuff to burn easy. So, that especially when I'm starting an engine. So the engine is cold. The engine's running slowly when I'm turning it with a starter. So I don't have quite as high a pressure, definitely don't have as high of temperatures in there. So that fuel is not going to ignite as easily. So I'd really like that auto ignition pressure of the fuel to be lower. So that would be like a lower octane would be better for a compression ignition engine than the higher octane is in the spark ignition engine. So what we do is we use a different number. Rather than lower octane numbers, we actually use a different number called a cetane number. And it's the same kind of thing. It's a number we calculate based on the properties of the fuel. But a higher cetane number means a lower ignition pressure, so that's better. So in both cases, with a spark or compression ignition engine, the higher number is better. Higher octane in gasoline engine, that's better for me. Higher cetane in a diesel engine, that's better for me. It's going to burn easier and so forth. So they're just opposite. There is actually a conversion where you can calculate one based on the other. But it's really just looking at that continuum of that auto ignition pressure. Okay, so again, we go back to this PV curve that we have looked at, that we've studied in the past, and we said that this corner right down here is the critical corner, right where I've finished that compression stroke and where I've got that air or the air-fuel mixture, depending on what's in that engine, I've got it compressed to its maximum before I ignite that fuel, however I do it, either with a spark or by injecting the fuel into that high-pressure environment. So this corner is critical. So for a gasoline engine, for a gasoline engine, I want to make sure that my auto ignition pressure is below that, because I don't want this, or the auto ignition pressure is above that. I'm sorry, I said that backwards. I want to make sure the auto ignition pressure is above this point so that I did not ignite that before I wanted to. Okay, I didn't ignite it while that piston was coming up. So for spark ignition, I want my auto ignition pressure up here. For a compression ignition engine, I want the auto ignition pressure of that fuel down here. So I want to be able to compress that air past the auto ignition point that's down below here somewhere, so that when I inject that fuel in there, it's going to be ready to burn. So it's the pressure's already high enough, it's going to start to burn as soon as I put it in that engine, as soon as I inject it. Okay, so that's the difference. Again, this is the critical point that we need to think about. All right, so what are the practical implications? First of all, let me say this. Octane and cetane have nothing to do with the energy content of the fuel. We just looked at energy content. We talked about so many BTUs per gallon or kilojoules per kilogram or whatever, however we measure that. Octane and cetane have nothing to do with that. So because I buy higher octane fuel, a lot of people think, oh, high octane fuel is high energy, my car is going to run better. Not necessarily, because there's no more energy in that. If your car can run well on low octane fuel, buy it, because you don't really get an advantage. There's no extra energy or anything in the higher octane fuel. If it runs well on low octane fuel, don't waste your money on the high octane fuel. Okay. Now, if you've got a car that has a higher compression ratio, some more advanced cars and more expensive cars, sometimes they'll have a higher compression ratio in there. And if you put low octane fuel in it, they won't like it. So they'll rattle. You'll get some knocking and stuff like that, because they've got higher compressions. They're a little bit closer to this crossover point there. And depending on the temperature of the engine and so forth, it may not operate well, may not run well. Okay. So that's the bottom line. It's not related to energy content. It's only how that fuel burns. So what does high octane mean? Let's think about spark ignition engines now. What does it mean for me? What are the implications? It's a higher auto ignition pressure, higher octane, higher auto ignition pressure. That means that I can have higher compression ratios. If I've got a higher octane fuel, I can have higher compression ratios. That expands this PV curve, lets me get a little bit more power out of that fuel, recover more power. That's why performance engines use ethanol. High octane, even though it's a lower energy, those higher pressures, I can still make this curve a little bit bigger and get more power out of it. So the high compression ratio is possible. Less knock and dieseling, so especially in cold weather, when the engine starts, when you're lugging up hills and stuff like that, if your engine knocks and rattles and makes some noise, it could be that the pressures are getting up higher. The pressures and temperatures are up above this auto ignition properties of the fuel. And so I may need to get a higher octane to keep that stuff from happening. So that's what the higher octane would do. So if I've got those kind of symptoms in my engine, higher octane fuel will take care of that. Now, it can have a cleaner burn, and I listed that there because, again, advanced engine technology, some of the controls and everything that we're doing in these advanced engines, they're changing the air-fuel ratios, they're changing timing, they're doing a lot of different things in the engine. And there is some things that we can do with that engine control to allow us to compensate better with the higher octane fuels. Okay, again, higher octane is a higher pressure before it burns. So I think about when I start to burn within that combustion chamber. So I'll light the fuel, and the fuel right by that spark starts to burn, and then I get this burning front that goes out from there. So it's like this flame that spreads out from that spark. And as that flame spreads out, it increases the pressure, of course, in the cylinder. And we know that because that's what's pushing the piston down. Well, that increase in pressure can sometimes cause funny things out in the farther edges of that combustion chamber to happen. So it can actually cause things to burn a little bit differently or burn earlier than I want to before that flame front gets across there, and burn without oxygen molecules near it and stuff like that. So I could have, with low octane fuels, sometimes not quite as clean of a burn, but again, that is very dependent on engine design, engine control, and so forth. In general, if it runs well on low octane fuel, use low octane fuel. Don't waste your money. Okay? So that's what octane. Now, higher cetane, again, we got to shift our thinking to this compression ignition engine. I want that stuff to ignite when I've got that low pressure, and even if I don't have as high a pressure. So again, during starting. So Higher cetane means a lower autoignition pressure. So that means less low speed knock and better cold starting. Again, when I start that engine, I'm getting those pressures up, but when I'm spinning the engine slow, I can't get quite as high a pressure. I definitely don't have as high a temperatures in there when I'm starting that engine, when the engine is cold. And so it's going to be a little bit harder to get that engine to go. So in that case, I want that fuel to burn easier. So I want that lower auto ignition pressure so that, I'm not getting the pressures as high, but hopefully it's high enough when I put that fuel in there that it's going to burn, the engine's going to start, and I'm not going to get knocking and so forth when it's cold. Okay, so that's what the higher cetane helps me with. So that's one of the advantages of biodiesel. It's got a higher cetane number. It burns a little bit easier. So it's easier to start the engine sometimes. Okay, so that's what helps us out there. All right, but here's the weird thing to think about, and we're going to come back to emissions later. It might give us higher emissions. So if we think about it, if it burns really easily, when I inject that fuel into that engine, that whole chamber is very compressed. It's got air in there, it's compressed, and I inject that fuel. What I really want to happen, what's really important to me, is that that fuel gets spread out all the way through that combustion chamber so that all of those molecules are paired up with air, with oxygen molecules from the air out in here, so that when it burns, I get a nice clean burn. Well, if that stuff burns too quickly, as those fuel molecules start out through there, and they burn too quickly, it might actually burn some of that up before those molecules get out to the edges where those oxygens are, and they didn't have that oxygen available. They didn't burn well. They didn't burn cleanly. And again, we'll see this when we look at the chemistry part of this. That's when I end up with some bad gases or weird stuff coming out of my engines, poor emissions. Okay, so sometimes it can actually be low emissions. So a lot of people say, oh, biodiesel, that's that biofuel. It's going to be a whole lot cleaner burning. Well, it could be, but it may not be. It all depends on the engine design. It depends on what's happening within that engine. So there's a lot going on there, a lot of complications. But again, the key things, understand that octane and cetane, understand how they're related to the autoignition pressure. The cetane is backwards, so higher cetane means a lower autoignition pressure. And understanding, going back to this PV curve that we've talked about, where that autoignition pressure falls, where that critical corner is and so forth. That's what we really need to understand and have our head wrapped around in terms of octane and cetane.